Hi students, so in this video I would like to explain one problem. Okay, so the question is something like this. There are two charges. One charge is positive Q1, other charge is negative Q2. Okay, this is negative, this is positive. And you know from the property of electric field lines that they start from positive charge and they end to negative charge. But these two do not have same value. Okay, so if this is 10 microcoulomb, this is not minus 10, it can be minus 15, minus 20. They are different charges. Okay, now electric field lines will go like this. They are asking you, if the electric field line here, you know that at any point on the line, if you draw a tangent, then that tangent gives you the direction of electric field. So if the electric field starts at an angle alpha, okay, then when it reaches here, what would be the angle of the electric field with respect to this line? They are asking for this charge. So they are asking relation between alpha and beta. So this is the question. Okay, so I hope the question is clear. Now you may be thinking that alpha and beta may be same. Okay, if it is a symmetrical, if it is like a parabola, nice parabola, then you know alpha and beta should be same. But here that is what we have to do. We have to find relation between alpha and beta. Okay, so the given parameters is Q1 and Q2. We have to find the relation between alpha and beta. Right? I hope all of you understood. This is your electric field line. Okay, electric field line. Okay. So to solve this problem, first you need to know something called solid angle. Solid angle. The symbol for solid angle we write like this. Okay, this is your omega. Okay, the Greek letter omega. Now, if it is a very small solid angle, we can write d omega. If it is a very small solid angle, we can write d omega also. Now, how do you define solid angle? So basically, solid angle is a partner of angle, but in 3D, three dimension. Angle is in 2 dimension. Okay, so if you take a circle and from the center you draw two lines to the circumference, then this is this angle theta is defined as the arc length divided by the radius. So that is the definition of angle. Okay, so you know that as you go farther from the center, suppose I go from this point number 1 to point number 2, then as you see, for this point this is your circle, for this point this is your circle. So as I go from 1 to 2, you can notice that the radius increases, right? But at the same time you can see the arc length also increases. So radius increases by some factor, arc length also increases by same factor. So the ratio of these two will be constant for these two lines. Understood or not? And that is why, since it is a constant, it is something useful, right? Something which is constant in a problem is always useful. So we call this as angle. Now this is in 2D. This is in a plane. Okay, circles are plane shape objects, right? Now imagine partner of circle in 3D. What is the partner of circle in 3D? Partner of circle in 3D will be sphere. Partner of circle in 3 dimension will be sphere. Okay, so imagine this is your sphere. Now in the board, no, everything will look like circle only. So this is a sphere. Okay, let me mention here, it is a sphere. Now for circle, we took a part of the circle as a arc. Here you have to take a part of this sphere. A part of a sphere will be a some area, right? So this is your area. Let us say this area is A. So this A represents this area. Now from that arc which we made in case of circle, we made two lines like this. Two lines we made. Now from this area, from the ends of this area, ends, okay, if you draw these lines, then it will form a kind of a, this kind of angle, but that angle is not in a plane. Okay, it is in space. So that angle is what is called as, this angle is what is called as solid angle, which is subtended by this area at the center. So you take some area, okay, and if this is the center, you draw these lines. So some kind of angle is formed, but that angle is not in a plane, it is in a 3D space. So we call such angles solid angle. Okay, so what will be the definition of this solid angle? Now if you again do the same trick, if you go from point 1 to point 2, you can see the radius increases, but you can see the area also increases. That time, no, the length, the arc length was increasing. Here the area is increasing, right, from here to here. So the ratio of area divided by, not r this time, r square. So this is area, no, area's dimension is length square. So area divided by this r square. Okay, this r is the radius from surface to the center. So area divided by r square will become constant like in the case of angle. But since it is in space, we have taken a part of a sphere. So there we took circle, here we took sphere. There we took part of a circle which is called arc. Here we took part of a surface which is a small area. Then we divided the arc length by radius. Here we divide the area by, obviously, radius square we have to do, because the area increases as r square. Yes or no? Their arc length increases with r. You know circumference is 2 pi r. So arc length increases with radius. Here area increases with r square. So the ratio will be some constant, and that is what is called solid angle. The unit of solid angle is steradian. Okay, steradian. Okay, so I hope solid angle is clear. Now I want to ask something very important. Okay, so listen carefully. Suppose I give you some circle like this. Okay, and I want to know at this point, okay, what solid angle this will subtend. Okay, so this is solid angle, maybe not omega. Okay, so I want to calculate this solid angle in terms of this half of the. So see, if you have a circle and then you want to find solid angle subtended by this area on this point, okay, then this lines you have to draw. No, if this is the circle, sorry, if this is the circle, from that circle you have to draw this kind of lines. So some 3D kind of angle is formed. That angle is called solid angle. Now this looks like a what? Cone. It looks like a cone. And every cone will have something called this angle. This is called your half angle. Okay. Okay. Half angle of the cone. So I want to find a formula for this solid angle in terms of this half angle. This half angle is basically angle only. It is a planar angle. Okay, so basically you imagine a plane, and then one line is here, one line is on this plane, and this angle is your theta. So this is like the first one that I explained, right? Angle I have explained, no, first one. So this is that angle. So I want this 3D angle omega in terms of this half angle theta. Don't tell me that this omega is twice of theta. Okay, that is nonsense, because theta is for planar angle. Omega is this 3D angle. Definition of these two are different. Angle is arc by radius. Solid angle is area by radius square. Okay. So we want relation between this. Okay. So how will we find the relation? So look carefully. So imagine this is the circle. Okay. Any circle, and at this point I want to find the solid angle. So basically what I should do is, let us imagine now a sphere like this. Please look carefully by diagram. So this is a sphere I have made. It may not look exactly like a sphere. This is a sphere. Okay. So this is the center of this imaginary sphere which I made. Now this distance from this to this will be the radius of the sphere. So basically what I have to do is, if I calculate this area, this cap area, it will look like a cap, no? This will look like a cap, right? So like this kind of cap it will look. So if I divide that area by this r square, I will get this solid angle. Yes or no? Because I am interested in this solid angle. Okay, so that solid angle will be this area of this cap divided by r square. So I want that in terms of this half solid angle. Sorry, in terms of this half cone angle, which is written as theta. Okay, so let us try to. So the whole derivation basically is to find this area. This area. Okay, so if I draw something like this, so that area I want. Okay, so let me remove this now. So how shall we find this area? Okay, so for that what I will do, let us take a small ring here. Okay, so this is a small ring which I have taken, because see I am interested in this area. Okay, this area I am interested, this area. Okay, it's a curved kind of area. So what I am doing is, basically I am dividing this area into thin rings. So one ring is this, then this ring, then this ring, like that, till I come to this ring. So like that. Okay, so if this is the cap, I am starting from this ring, then this ring, then this ring, till I reach the last ring, till I reach this ring. Okay, fine. So I hope you understood this concept, right? This kind of surface can be thought as made up of rings, small rings. So what I'm going to do, I hope you have understood. I'm going to calculate area of one small ring, then I'm going to integrate. Okay. So let us do that. Okay. So I want to know this area. Okay. Area of this ring. Other part is that side. Okay. So if I try to show it more, a little bit bigger, let me try to show. Okay. So let me draw the sphere first. Okay. So this is the sphere. This is the center. Here is the circle. It is the circle. So I'm interested in this area I told, right? So what I'm saying is, I'm taking an area which is something like this. Okay. And that side it will go like that. Okay. Okay. Fine. So I want to know this area first. This is on the back side. Okay. This part is on the back side. Okay. I hope everybody is understanding. So let us say this makes with the vertical some angle. Okay, not there. Okay, because I want from center, right? So let us say this strip or this ring makes an angle phi with the vertical. Okay, then this small angle here will be d phi. Yes or no? That means this thickness, of the ring can be written as r d phi. No, you know this from the formula for arc. So the small arc here can be written as this small angle into this radius. And you know this whole thing is radius of this sphere. Okay, now? Okay. So what will be area of this small ring? So area of elemental ring. Elemental ring. Elemental here means, element means what? Basically part, no? Part of this. Basically, see, I am interested to know this area of this cap. Directly, though I don't know. So I am trying to find first area of this ring in terms of given quantities. Okay. So area of the elemental ring will be, let us say dA. That will be equal to how much now? Now for a ring, if I give you a ring like this, if this is R and this is dr, it is very thin, thickness is very small, then what will be this area? So area of this ring, I can write pi r plus dr square minus pi r square. Yes or no? So this big area minus this small area will give me the area of the ring. Right? This total area is pi r plus dr square, and this small area here is pi r square. Now if you open this, you will get pi r square plus dr square plus 2r dr minus pi r square. Okay, so the first term, see, pi r square will cancel with minus pi r square, and this dr square, dr itself is very small, so dr square will be negligible. So what will be the area? 2 pi r 2 pi r into dr. Okay, so basically it is length of this into thickness. Okay, so if you basically, if you cut this, if you cut here and open it, it will be approximately a rectangle, right? And this part, this is the circumference, so this length will be 2 pi r, and this thickness will be dr, right? So if you cut this and open, this ring will become like this rectangle. Understanding or not? So area of that will be what? Length into breadth. So basically the length is 2 pi r into dr. Now the radius of this ring is not this r, okay? This r is radius of the sphere. So radius of this ring is this, yes or no? And that radius will be how much? This is r, this is phi, so this is opposite side, so this will be r sine phi. Correct, no? So area of the ring is 2 pi radius of this ring, which is r sine phi, right? I'm using this formula, okay? 2 pi radius into thickness. So radius of this ring is r sine phi, and thickness is this part, and that is your r d phi. So very nicely, see, limit variable has come. Okay, now my aim was not to know area of this small ring. My aim was to know area of this cap. Area of this cap, let me call it, because it looks like a cap, right? Okay. So I hope you have understood whole thing. Make a note, okay? Make a note. All these things are very important. So once I know the area of that small ring, let me again explain to you. So this was your circle, remember, and this was the center. Don't forget the main question, okay? Then I made a sphere like this, right? Like this. Yes or no? So I think better I draw the sphere first, okay? So first, so this was your cap, and this is the center. Okay. Now this angle, half, see, this will be a cone, okay, here, and half of that cone is your theta. Half of this angle is theta. Now I was interested to know this area of the cap, right? This area. So that area, now I can divide from this ring, then I go to 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 this ring, till I come to this ring, the last one. That means my theta should increase from 0, because I'm starting from this ring, right? So when I start, see, this is area of one of the rings here, and that time the angle was this phi. You're understanding, right? So that phi will go from 0 till where? Till theta, right? So from keep theta 0, then make one circle. That will be having no radius, because theta 0 means here itself, no? Then you make theta little bit this much, then you go round like this. Then you will get one ring. Then you go theta here, then make one round. Then you get one more ring. So like that, starting from this point till you reach this circle, which was actually our question. So our phi, this variable phi, has to go from 0 degree till theta degree. Understanding, right? Because we have to start from this ring till I go to this ring. So my variable phi goes from 0 to theta. So the total area of the cap, which I am interested, okay, because once I choose one phi, I am covering this area, no? So once I reach this theta, I will cover this area. So my area of the this cap will be integration of this area. Okay, so add all these small areas. So now I don't need this. So if you add all that area, what will be the area of the cap? Tell me. 2 pi r square is constant. 2 pi r square is constant. What is left? Integral of sine phi d phi. And phi should go from 0 to theta. Okay, and don't forget what was theta. Okay, so this is 2 pi r square. Integration of sine phi is minus cos theta. Upper limit theta, lower limit 0. So 2 pi r square, put upper limit minus cos theta, minus, put lower limit. So it will be minus cos 0. So that will be 2 pi r square, minus minus is 1, cos 0 is 1, right? Sorry, minus minus is plus, cos 0 is 1, then 1 minus cos theta. So this is the area of the cap. Okay, so once we know the area of that cap, the solid angle, okay, so make a note of this quickly, or you can take a screenshot. So what is the area of the cap we found? So this is your ring, and this was the point, and I wanted, the main question was to know the solid angle, okay, in terms of this half semi-vertical angle of the cone. So how to find the solid angle made by this cone? So solid angle made by this ring at this point will be this area of the cap, okay, because you have to imagine a sphere, no, to define solid angle. So define a sphere. So basically whatever angle this will subtend, same thing this will subtend. Whatever solid angle this will subtend, same this will subtend. Okay, so the it will be equal to, so what was the area of this part of the sphere? 2 pi r square 1 minus cos theta divided by what we have to do, divided by r square, right? So solid angle subtended by the cap will be area of the cap divided by r square. So that will be 2 pi 1 minus cos theta. So forget about the derivation now, try to memorize this result. So this is the relation between angle subtended by a circle at some point in terms of half of this whole angle. So this is your normal angle which you study from school days. This is a solid angle. So this is basically, you know, from every point on this circle you draw lines like this. So this 3D angle is what is this. But if you draw like that, no, it becomes very dirty, right? Okay. So I hope you all understood this. So 2 pi 1 minus cos theta. Now let us come back to the original question. So here was your charge plus Q1, and here was your charge minus Q2, and the lines are going something like this. Okay, so now this makes an angle alpha and this makes an angle beta. Okay, now look carefully. The lines of electric field which starts like this. See, lines of electric field go in all directions for positive charge. So those lines are bent and reaching here, some of those lines. But one thing is very clear, whatever lines start from here, that must enter, whatever lines, see, this line is going here means this line will go somewhere here. This line will go somewhere here, and this line will go straight here. Okay, fine. And this number of lines is proportional to the charge. Okay, so that is obvious, right? Number of lines is proportional to the electric field in a given region. If lines are closer, electric field is stronger, and electric field in turn is proportional to the source charge. So number of lines is proportional to the value of the charge. Okay, now how many lines are going through this angle? Suppose I want to know. Okay, through this angle. Okay, whatever lines are passing through this angle. So what you do, you make a cone here. Okay, so whatever lines, okay, same thing you can draw here also by the way, okay. So how many lines are going through this cone if I ask? Okay, so the number of lines is proportional to charge first, you have understood, right? Now how many lines are passing through this area, suppose I ask? That can be found this way, okay. So let me rub this part, remember this, okay. So number of lines passing through solid angle omega. So what solid angle? This, see this circle here will make some solid angle here, I have told. That is not alpha, okay. Alpha is your normal 2D angle, okay. Alpha is your normal 2D angle which they have given in the question. But you know that lines will not go this way, no? Lines will not go in a plane. Lines will go like this, okay. So lines will go through some 3D space. So the number of lines passing through solid angle omega will be equal to total number of lines divided by total solid angle into the solid angle through which you want the number of lines. I hope it is clear, okay. This is like asking what is price of 5 apples, okay. So it is total price divided by total number of apples into price of 5 apples. Now the total number of lines will be proportional to the value of the charge, okay. This will be proportional to the number of lines will be proportional to the value of the source charge, because this is proportional to the electric field, okay. And that divided by total solid angle. Total solid angle will be 4 pi. Yes or no? For full, because the lines will spread in all direction, no? So nearby here, this charge will have almost no effect. So while starting, it will start in all direction like this. Okay. So total solid angle for a sphere is how much? 4 pi, right? What was the formula for solid angle? Area divided by r square. Now what is this A? This A was part of the area of the sphere. If you want maximum solid angle, maximum, then you have to use maximum area. Maximum area means full area. Full area of sphere is how much? 4 pi r square divided by r square. Right? So just like angle is what? Arc length by radius. What is the maximum angle? 2 pi, because maximum arc you can imagine is full circle. So full circle length is how much? 2 pi r divided by r. So that will be 2 pi. So just like maximum total angle is 2 pi, same way maximum solid angle is 4 pi. So total number of lines is proportional to the charge. Okay, so I'm writing proportional, okay, not equal to. And total solid angle is 4 pi into omega. Okay. Now, but one thing I know, whatever lines pass through this cone must also go through this cone, right? If I imagine a cone like this. So whatever lines come out from here must go here also. That is 100%. Understood or not? Because the topmost is going like this, no? So inner ones has to go there only, where it will go. Understood or not? So the number of lines passing through this must be equal to passing through this. Okay? So this is the number of lines passing through this solid angle. Similarly, number of lines passing through this solid angle should be same. That means this part, this one, because if I write equal to also, some constant will come. It will be constant only. So this should be same for this also and for this also. Now for this, what is this? If I ask Q1, solid angle here is omega 1, let's say, divided by 4 pi. And for this, what it will be? Q2, magnitude you write. We are counting number of lines. Number of lines cannot be negative. So Q2, solid angle here, divided by 4 pi. So 4 pi gets cancelled, right? So that means your omega 2 divided by omega 1 will be equals to Q2 divided by Q1. Now omega 2 will be what? See, this beta is the semi-vertical angle of this cone. And how to write solid angle in terms of solid angle subtended by a cone in terms of semi-vertical angle of the cone? I told you 2 pi 1 minus cos semi-vertical angle. Here what is the semi-vertical angle? Beta divided by 2 pi. Omega 1 is the solid angle here. There will be 1 minus cos alpha equals to q2 by q1. Okay, so you can now cancel 2 pi 2 pi, and if you cancel 2 pi 2 pi, you are left with 1 minus cos beta. 1 minus cos theta is 2 sine square theta by 2. So I can write this as 2 sine square beta by 2. And this one I can write 2 sine square alpha by 2 equals to q2 by q1. And 2 also cancels. So finally sine beta by 2 divided by sine alpha by 2 will be equal to square root of q2 by q1. So this is the relation between alpha and beta. Okay, I hope everybody understood. So the main thing here is the total number of lines starting from this charge should be proportional to the magnitude of the charge, and that comes from directly the properties of electric field lines. So closer the lines, more number of lines will be there compared to, suppose I give you two charges, here plus 10 microcoulomb, here plus 20 microcoulomb. Then while drawing the lines, if you draw here like this, 1, 2, 3, 4, 5, 6, here you must somehow draw 12 like this, okay? So I don't know how many I've drawn, but it should be 12 because the closeness of the lines is proportional to the magnitude of the electric field, and electric field in turn in magnitude to the charge. Okay, so hope everybody understood. So just go through this derivation once. So let me just remind you, if you have a circle and at this point if you want to know how much solid angle it makes, how much solid angle it subtends, then that solid angle can be written in terms of this half cone angle. This is your cone angle, so this is called your semi vertical angle, like that. Okay, so the formula is 2 pi 1 minus cos theta. So try to memorize this later. In later problems when we will start electric flux, that time this will be very useful. Okay, see you next class.